Alright, good day everybody. We are welcome back to another session of mathematics. The last class we started trigonometry. Now we want to continue with it. Before I start, I want to appreciate and thank my viewers, my subscribers that used to comment on my video, I used to like. Thank you so much. Now let's continue. Trigonometry. Last class I did trigonometry is a branch of mathematics that deals with the relationship between sides and angles of a triangle, especially a right angle triangle. I give us types of triangle, equilateral, isosceles, scalene, and so on like that. And the one that concerns us here is the right angle triangle. I said the right angle triangle has 3 sides and 3 angles. But one of the angles is known to be 90 degrees. As I have something like this, it means it is 90 degrees. Then the 3 sides of a triangle are labeled based on the side this angle faces. So if it's facing this side, we call this the opposite. Call this opposite. We call the other side here the adjacent. And we call this side, it's known, it's constant, we call it the hypotenuse. I'm going to talk about sides today. Next class we'll be talking about angles. So in this side here, there is a theorem I want to bring out from here. We call it the Pythagoras theorem. Theorem that has been proved, tested, and trusted over the years. Pythagoras is the name of somebody. Theorem is a rule used in solving problems that involve a right angle triangle. Pythagoras is a Greek philosopher, is a Greek mathematician that postulated a rule that we can use in solving a right angle triangle. So what does Pythagoras theorem state? It says hypotenuse squared is equal to opposite squared plus adjacent squared. This is what we call the Pythagoras theorem. Hypotenuse squared equals opposite squared plus adjacent squared. Let's take for example, this Pythagoras is used to find the sides of right angle triangle. Let's take for example, I have a given right angle like this. Here we have 3 and here is 4. This here I'm talking about now, we can label it to call the opposite because it's the side facing the given angle. While this side is constant, we call it the hypotenuse. I'm shortening their name. Then here, the other remaining part, we call it the opposite. So if I ask to find the hypotenuse, since opposite and adjacent has been given, so we can make use of the Pythagoras theorem, which says the hypotenuse squared is equal to opposite squared plus the adjacent squared. The hypotenuse I'm looking for, let's make it x squared equals the opposite 3 squared plus the adjacent, which is 4 squared. So I'm going to have x squared equals the square of 3, that'll give us 9, plus the square of 4, which will give us 16. So we now have x squared equals 9 plus 16, and that will give us 25. So I'm going to root both sides. These cancel these. This is law of indices that we discussed before. Then the square root of 25 will give us 5. We can say the hypotenuse is 5. The hypotenuse is going to be 5, greater than 3 and 4, because hypotenuse is the longest part. The longest part of a right angled triangle. But if it's not hypotenuse that is given, then we have to find. If it's opposite, we can use our change of solid of formula. If, for example, in a situation whereby I'm asked to find the opposite, I'll say opposite squared. This adjacent term come here. That is hypotenuse squared minus the adjacent squared. If it is the adjacent we are looking for, it's going to be the adjacent squared equals the hypotenuse squared minus the opposite square. So I can say these are ways of finding or of getting any of the three parts in a right angle triangle that is not given. Okay, I'm going to stop here till we meet again. But before I go, let me put this as an assignment or just try it. If you have the adjacent to be given as, okay, let me draw a right angle triangle like this, and I'm giving my angle to be here. This opposite is given to be 5, and the hypotenuse is given to be 13. Now find the adjacent. Find the adjacent. Anybody that do it, that can be able to do it, please drop your answer in the comment section. Till we meet again, like, follow, and share. God bless you.